Hey guys, this will probably be a quick homework video. Factoring by grouping is not a concept that's been totally over anybody's head, so it's just a couple quick practice problems. I'm just going to randomly pick a couple. Why don't we do E and F? So if we're going to factor by grouping, the first thing we're going to do is make sure that if we group it like this, we'll be able to have some like terms or some things that they have in common that we'll be able to factor out. So if I group it this way, I will have something in common with these two terms. I'll definitely be able to get at least an x squared and a 2 out of here. And over here, 5 is a factor of 30, so there will be something here to work with as well. But I also have to be careful that if I'm going to put these parentheses here like this, I have to change this plus 5 to a minus, or change this minus 5 to a plus 5 rather. Because by adding this parenthesis, I'm now expecting to distribute this negative, so this negative 5 is really a positive 5. All right. Now we can pull the things out that each term has in common. This term shares with this term a 2x squared, so I can get that out of there. That's going to leave me with a 6x plus 1. Now over here, these two terms share a 5. So if I pull a 5 out, I'll have a 6x plus 1. And that makes things really nice for us because we can group this whole thing now and do what we just did, but on a much larger scale. They each share this piece, so I'm going to get that out of there. 6x plus 1 is a common factor. And if we divide both terms by 6x plus 1, I'll be left with 2x squared minus 5. So that is what's going to go in our second set of parentheses. Now all I have to do is just make sure that neither of these two things can be factored any further. And this really we could factor that using completing the square or the quadratic formula, but it can't be double bubbled. So in this case, we're just going to leave it the way it is. We just have to recognize that this does have two factors. They're just not nice factors. All right, there's E. Let's do F. F is a similar problem. We have this negative here, so we're going to have to make sure we be careful of that. If we put this parenthesis here and this parenthesis here, we're going to have to make sure that we acknowledge, and I could really just draw over it in white, I guess. Let's do that. That addition sign now has just become a subtraction sign. Because we put that parentheses there, we're distributing that exponent now. So we have to make sure that we acknowledge that what was a plus 15, in order for it to stay a plus 15, we have to make this piece be negative so that when this negative is distributed, it goes back to being the positive 15 that it was. So we haven't changed the value of anything now. Over here, we have a 4n squared that looks like would be our GCF. And that's going to leave us with n minus 3. Over here, it looks like we could take a 5 out of both of these. So if we take a 5 out, then we'll have an n minus 3 over here. That makes things really nice because if we do this grouping method on a much larger scale now, both of these terms have an n minus 3. So that n minus 3 is going to be the thing that we remove. That's going to leave us with the 4n squared minus 5. And we do have to recognize that 4n squared minus 5 can be further factored. We would have to use the quadratic formula or completing the square to do it, so we're just going to leave it like this for now. If this was something we could double bubble, then we would definitely do that. 4n squared, that's all a perfect square, and we are subtracting. If this was a 4 or a 16 or some other perfect square, we would have to double bubble it using difference of perfect squares, but unfortunately we can't here. All right, guys, so that's E and F. Hopefully that was helpful. I don't think that this will be too crazy of an assignment. So you got 6 of them to do. Pick 4 more, and I'll see you guys tomorrow.